Hey guys, let's look at some more chemical mixture puzzles. These are called type B. But first, let's do an oldie. And we're going to mix up some iced tea here. All right, we got some tea that's 90% sugar. We got some tea that's 70% sugar. We're going to clunk them both together. And we're going to get some tea that's 78% sugar. In fact, we're going to get exactly 100 gallons of it. All right. So let's go back and review how we do with these kind of problems. So if you want to visualize this, what you're doing is, here's a clunk of tea. Here's another clunk of tea. You're going to pour it into this, 100 gallons here. And then this is going to be what? 78% final, right? And you're going here and then there. And that's 70%, and that's 90%, and then how much of each you're going to put together. Okay, well, first you need two equations. Since you have two things that are not known, you need two equations. So the first basic question, you're going, okay, I'm adding something, whatever it is, plus something else, whatever that is, and I'm going to have 100 gallons. How do you write that as an equation? I'm adding two things I don't know, and I get 100 gallons. Well, of course, that'll be like this, right? X plus y equals 100, right? Okay. The second thing is I'm adding something that's 90% to something that's 70%, and I'm getting something that's 78%, okay? So again, we're going to go, 0.9 times some amount we don't know, plus 0.7 times some amount we don't know, equals 0.78, but that's going to be, we know how much it's going to be of that. It's 100 gallons, okay? So there we go, we got it. And all we need to do now is either eliminate or substitute. In fact, let's just go ahead and write, this will be 78, right? Okay, that's 0.78 times 100. Let's go ahead and get rid of these decimals and make them into integers. So let's go ahead and move it all the way over. So we get 9x plus 7y equals that times 10. Of course, we move it, we move the decimal over one time. There you go. And there's our original equation. We got x, we got y, and we got 100. Okay. Don't like this. I'm just going to use elimination. So I'll multiply the whole bottom by 9. So 9x plus 9y is 900. Okay. And I'll subtract. Goes away. 7 minus 9 is negative 2y. 780 minus 900 is negative 120. So we have y is equal to 60. And of course, it's 100 gallons total. X is going to have to be equal to 40. Now you can very quickly, if you want to check this and go, okay, my y is the 70%. Okay, if I do 60 gallons of that, how much is actually sugar? What is 70% of 60? In other words, what's 0.7 times 60? 70% of 60 is 42. That's how much sugar there is in that part of the tea. The other part has 90% sugar, but there's only 40 gallons of that. Well, what's 0.9 times 40? In other words, 9 times 4, that's 36, right? That's how much sugar is in there total. That gives me 78 if I add those, which is exactly the percent we want. Just to check, you don't have to do that if you don't want to. Okay, let's look at the second type we're going to do. And you can write this down in your notes if you want to. How much water must evaporate from 100 gallons of a 10% brine solution, brine is salt, to get a 40% brine or salt solution? Okay. All right, well, let's visualize. I got some brine solution. It's sitting here in a pot. All right, there you go. It's 100 gallons. And let's say it's like, there's the salt. It's all mixed in, but I just put it at the bottom so you can visualize. It's 10% salt. How much water is going to have to go, evaporate from that to where this salt is 40% salt of whatever that solution is, okay? Now this is, actually, these are kind of funky at first, but they turn into easier ones because the nice news is you only need one equation, no, not two, okay? Only one equation is all you're going to need. So write this down. I've made this really simple for you as opposed to how the book does it. All right, step one, choose one ingredient in the mix to work with, either salt or water, whichever one you want. All right, I have a question for you. When you sit there and leave a brine or salt solution and it evaporates, does the salt evaporate? No, it does not. Only water evaporates, okay? That's a key part of our equation. We'll get to that in a second. Okay, choose one ingredient in the mix to work with, either salt or water, or either, I don't know, Jello or pudding. I mean, you know, whatever. I mean, whatever you're mixing together. Just choose one to work with, leave the other one behind. Second is decide either a plus or a minus for the equation. Decide either plus or minus for the equation. Okay, third, write this equation, and you can pause this, but look at the equation. It's percent of the start amount plus or minus, whichever one you need to do, the change amount equals the percent of the final amount. And you can use that for all of these. All right? So let's actually try this. And of course, you can obviously pause this if you haven't written this all down, but go ahead and write that. All right, let's take a look. How much water must evaporate from 100 gallons of a 10% brine solution to get a 40% brine solution? All right, well, let's do the brine, or I'm just going to call it salt. Okay, we'll do this one way. Okay, here's how you do it using salt. Okay, well, let's go back and look. You're going to say, oops, that's a butterfat problem. Here we go. Okay, we'll come to that in a second. All right, choose one ingredient to work with. Decide either plus or minus. Write this equation. Let's look at step 3, the percent of the start amount. Okay, well, we're working with brine, so let's start with that. That's 10% brine or salt. Okay, so we'll just write 0.1. And then how much do we have? 100 gallons. We'll write that. Okay, that's the way we start. All right, next, plus or minus the change amount. Okay, well, how much water has to evaporate from 100 gallons of and so on? Well, we're not working with water. We're working with only salt in this one. So we're going to go, okay, well, minus, okay, well, how much salt is evaporating from this? None, right? That's it. You can just write 0. No salt is evaporating, okay? We're going to get a 40% brine solution. Now look at step 3. Look at that part of the percent times the final amount. This is the key. What this means, let's just translate this so far. You have some solution that's 10% salt, right? 0.1 times 100 gallons of salt, they tell you. How much salt goes away? Because they're asking you how much water is going to evaporate. We're not messing with water in this one. So we're not subtracting anything out of the salt. Okay, it's going to equal, now you tell me, what should this be? What number should we put here to put 40%? Because that's what we want, is a 40% brine solution. We're going to put 0.4, right? Okay. Now the question is, here's the question. We have 100 gallons, right? Okay, well, some goes away. In other words, some evaporates. How much do we have left? How do we write that? If we started with 100 and some goes away, how do you write that if you don't know how much goes away? You're going to write, you started with 100, some goes away, we don't know how much it is, and that's it. That's all you need to do. Okay, so look, let's solve the equation now. 0.1 times 100, of course that's 10, right? Minus 0, go away. 0.4 times 100 is 40, right? Now, this is where commonly mistakes get made. Don't just write, oh, minus x, because you have the 0.4 times the minus x. So make sure you write 0.4x, okay? And let's just do this. I despise x as being on the right. I'm just going to move it over here. So I'll have a 0.4x on the left side. I'll move this 10 over. That's going to be 40 minus 10. That'll be 30, okay? And I'm sure if you want to use a calculator, you can do this. You can just go, okay, 30 divided by 0.4, and you're going to get 75. All right? And there we go. In other words, what you're saying is that 75 gallons out of that 100 gallons has to go away. By the way, if 75 gallons goes away, how much water do you have left? Or how much solution do you have left? 25, right? Okay. You still have 10% of 100 is 10 pounds, let's say 10 gallons of salt, right? If you still have 10 gallons of salt, it's still there. Salt doesn't evaporate. But you only have 25 pounds of the solution left because the 75 went away. 10 divided by 25 is 2/5. If you reduce it, what percent is that? 40%. There you go. Okay, that's one way. Let's do the water way. We're going to do the exact same equation as here, as this one, except we're going to do water instead. Let's just practice doing it. Try not to look at that equation, all right? This is going to be the water way. Okay, so we're going to start. Okay, what do we have? We have something that's 10% salt, and there's 100 gallons of it. Well, if it's 10% salt, what percent of water is it? 90, right? Okay, so we're going to go 90% of this stuff is water. Okay, now how much must evaporate? Which means it has to go away, be subtracted, right? Well, we don't know the answer to that. If we knew the answer to that, we'd have to go through all this torture. Okay, but we have to subtract some amount. We don't know what it is. Just call it X, right? Boom. Okay, so 0.9 times 100, that's the percent of water we have in this solution. We say we're going to subtract something, the water. We don't know how much. What are we going to end up with? We have 100 gallons. And what do we want percent of water left? If it's 40% salt, what percent water is it? 60%, right? We'll just write 0.6, okay? And again, it's the same thing. We can go, we started with 100, we subtracted some. How do you write that? Well, it's the same way as we did before. We started with 100, we subtracted some, we don't know how much. That's it. In other words, let's read this together. We've got a solution that's 90% water. Some water evaporated. We don't know how much. That's the subtract, right? We ended up with 60% water, and the amount we ended up with, I don't know how much it is. I know it used to be 100 gallons, but we subtracted some amount. I don't know. But the thing is, the value there, the variable was exactly the same one. So we can solve this equation just by doing one equation. Okay, so let's do it together. 0.9 times 100, of course, 90. Minus x, all right? 6 times 100, 60. Don't forget, this is 0.6 times that. So it's going to be negative 0.6x. Okay. All right, well, let's get x on the left side. Let's move 90 over here, and we'll go 60 minus 90 is negative 30. Now over here, we can just call this negative 1x if you want to, okay? And you're going to want to go, okay, well, I have negative 1x, and I have a negative 0.6, which turns into, I'm going to have to add 0.6, right? So the question is, what's negative 1 plus 0.6? And the answer is going to be negative 0.4x. Okay, and you can do the same thing here. Divide by negative 0.4, divide by negative 0.4, and you're going to get exactly the same thing. Look at that over there. We got 30 divided by 0.4, same thing. It's going to be 75. Okay, and again, let me just really quickly. On the salt one, you go, okay, I have 100 gallons of something, and it's 10% salt. I'll write it like that. Okay, that's what I've got at first. I'm subtracting something, but wait a minute, nothing's going away because salt doesn't evaporate. So I'm subtracting nothing. You don't even have to write a negative 0 if you don't want to. But I'm going to end up with something that is, let's see here, 40% salt. The amount I'm going to end up with, I don't know how to write it. I mean, I know it used to be 100. I subtracted some amount. I'll just write 100 minus x. Boom, there you go. The water way, you look at it and you go, well, I know I've got, this thing has 90% water in it. I'll just put 0.9 times 100 gallons, okay? I'm subtracting some amount because, yeah, this represents the water. It's evaporating all right. Oh, yeah, that's going away. That's gone. It's 100, you can write a 1 there if you want to because, the water that evaporates, what percent of water is water? 100%, not like 90 or 60 or whatever. Okay, I'm starting with something that's 90% water. I'm evaporating the water, don't know how much. I'm going to end up with something that is, let's see, 40% salt means 60% water, boom. The amount I end up with, I don't know, I have 100 I started with, I'm subtracting some amount, I'll just put it like that, and yoink, you've got it. Because you only have one variable, you just solve it, there you go, okay. All right. Either way is good. Okay, let's try another one. There's a lot of these butter fat ones, okay? It's probably goat milk because these are homeschoolers, I'm thinking. Okay, so anyway, all right. Ed had 900 pounds of milk, a lot of milk, big cow. That was 2% butter fat, okay? how much butter fat did he have to add? This is going to be a plus one. Instead of that, ooh, the water went away, we're adding pure butter fat to this to raise the butter fat content to 8%. Okay, in other words, here's some milk. Here's a big hunk of it. It's very large. There's Ed. Okay. It's 900 pounds, for heaven's sakes. There it is, 900 pounds. Okay, and it's 2% butter fat. And he's got a little thing, got a little container here. This is butter fat, all right? This is 2% butter fat, right? Well, I have a question for you. What percent of butter fat is butter fat? 100%, right? Okay, so keep that in your head, all right? So this is an addition problem, okay? So let's start with this. The dude has 900 pounds of milk that's 2% butter fat. How do you write that as some part of an equation? He's got 900 pounds, 2% butter fat. You're going to write 900, right, times what? 0.02, right? Don't put 0.2, that's 20%. Okay. Now, he's going to add some butter fat. Well, I don't know how much he's going to add. So what are you going to write? Just write B, right? We don't need to put 0.02, anything like that. This really means 1. That's 100% butter fat, right? In other words, this is 2% butter fat. We're putting 0.02. This is 100%. We're just putting a 1 there. Okay, that's butter fat. All right. How much did he have to add to raise it to 8%? Okay, in other words, he is pouring something we don't know. Well, he'll know, but we won't know yet. He's pouring something into this, all right? We don't know how much this is, and we don't know how much this is going to be to the end of this, okay? We don't know. That's what we're saying he's going to pour in there. We also don't know how the heck much this is going to be either. But let's say this. If the guy starts with 900 pounds, and then he pours in something else, well, what are we going to call that? Right, okay, we're going to call that, okay. In other words, they want it 8%, right? Okay, so the final number we're going to write in front of our hunk, which we don't know yet, is going to be 0.08, right? Okay, now again, he starts with 900 pounds, he adds something. How am I going to write that inside this equation? I mean, inside these parentheses. He starts with 900, he adds something, there you go. In other words, here's Ed. He's starting out with a hunk of milk, 900 pounds, 2% butter fat. He adds butter fat, which is by definition 100% butter fat, okay? He ends up with some amount. We don't know how much it is. We know it's 900 plus whatever he throws in there. And we know the new percent is 8%. Boom, there you go. Okay, well, let's do it. 0.02 times 900 is 18. Plus B, 0.08 times 900 is 72. Plus, don't forget, this is not just B, it's 0.08B. Okay, so we'll move the 18 over here, subtract that from 72, that gives us 52. Then we have 1B minus 0.08B is 0.92B. To find out what 0.9 or B is, you divide by 0.92. All right, and here we go. We have 54 divided by 0.92. There it is. I thought that's what it was. Let me try it again. Equals 58. We'll call it 58.7. Okay. So the answer is he is going to dump 58.7 pounds of butter fat into his, giant lump. Okay. By the way, if it's 2% butter fat in that 900 pounds, then he's got 18 pounds of butter fat in there, right? Okay, so that's over here. If he adds this butter fat to it, he's going to have a total of 76.7 pounds of butter fat, right? Okay. Now my question to you is, how much complete milk stuff solution, whatever you want to call it, is there now? If there used to be 900 pounds and he added this much in there, well, obviously there's going to be 958.7 pounds of that mess. Okay. Well, my question to you is, look at this. That's the amount of butter fat in there. And that's the amount total now he's got. Let's take a little calculating ourselves and go, okay, well, I've got 76.7 divided by 958, excuse me, 0.7. That equals, boop, there we go. Now look at that, 0.08. What does that mean to you? Excuse me. That's 8%, right? In other words, we've just proved we're right. Let's go back one more quick time. Look at this. We start off with 900 pounds, that's 2% butter fat. There it is. We add something. I don't know how much butter fat, but we know it's, as far as percent goes, it's not that and it's not that, it's 100%, that's a 1. We end up with an amount, we don't know how much, it's 900 pounds plus something, and it's 0.08%. There you go, there's your equation. Okay, let's try one more. Bill and Hillary had 100 pounds of a 20% arsenic solution. Excuse me. How much of a 40% arsenic solution should they add to get a solution that is 35% arsenic? Okay, well, we can draw a little quick picture here, right? Okay, they've got 100 pounds of an arsenic solution. There it is, 100 pounds, and it's 20% arsenic. Now they're going to have to add something, pour it in there, and that's going to be 40%, right? And they want to end up with something that's 35%. Okay, well, we can do this, no big deal. Okay, so we have 100 pounds of a 20% arsenic solution, right? How do you write that? What can we write? 100 pounds of something that's 20% arsenic. Okay, yep. I think I heard you say this. 0.2 times 100, right? All right. So they say we're going to add how much of a 40% arsenic solution? Okay, well, we know 40% will be 0.4, right? Well, how much do we add of something? If we don't know how much we add, we're going to have to go, okay, here we go. Don't know, but I'll put it right there. Okay, so now we're going to get a solution that's 35% arsenic. So you can just go, okay, well, I got 20% of 100 pounds. I'm going to add 40% of don't know what. All right. So what is your final amount going to be if you start with 100 pounds and you add something you don't know how much? 100 plus X, right? Okay. Well, it's 35% arsenic. You're going to go 0.35. Okay. Pause it and go ahead and solve that. Okay, let's do it together. 20 plus 0.4x equals 0.35 times 100 is just 35 plus 0.35x. Okay, let's move 20 over to the right, and that gives us 35 minus 20, 15. Let's move 0.35 over to the left. That's going to give us, if you want to go 0.4 minus 0.35, that gives us 0.05. Equals 15. Now if you want to just go ahead and go, okay, I'm just going to do calculator, divide 15 by 0.05. That'll give us 300. Okay, there we go. All right, there it is. My question, really very quickly, 30 seconds, we can prove that we're right. If you have a big bag, 100 pounds of arsenic solution, it's 100 pounds of arsenic with 20%. That means there are 20 pounds of arsenic in it. Okay? If you add 40% arsenic solution, we're claiming that the answer, how much do you add of this 40? We're saying it's 300, right? Well, you can go over here and go, okay, well, 40% of 300, in other words, 0.4 times 300, and that'll give you 120, right? So altogether, we have 20 plus 100, 140 pounds of arsenic, okay? The question is, how many pounds of the entire thing do we have now? Look at it. How many pounds of the entire thing do we have? We started with this, and we ended with this. What do we have? We started with 100, right? We added 300, right? So we have 400, right? That's the arsenic amount of that. If you stick in your calculator, go ahead, pause it for a second, put in your calculator 140 divided by 400. Pause it and do it. Okay, if you did it, you would find out this is your answer, 0.35. What does that mean? That means that the arsenic part of this entire solution is 0.35, which is exactly what we are looking for. There you go. Okay, that's how you do it. All right, let's try a practice problem, and go ahead and pause it, and we'll do it together. Okay, I'm gonna do this both ways. Let's do the salt way first, or brine, whatever. Saline, same thing as salt. Okay. All right, how much water must be evaporated for 400 gallons of a 15% saline solution to get a bottle of? Okay, so in other words, we start off with 400 gallons, that's 15% salt, okay? The way we write this is we go, okay, that's 15% salt times 400 gallons, all right? How much water do we evaporate? Well, how much salt gets evaporated? None, right? If you want to write minus 0, go right ahead and do it, okay? Because nothing's going to be evaporated, all right? We get a 40% saline solution, salt. In other words, the whole amount is 40% salt, okay? The question is, if we started with 400 gallons and we evaporated some amount, how do you write that? Well, you start with 400 and you go, I minused, or I took away some amount that I don't know how much it is. And there you go, look at that. You only have one variable to solve, you got it. 0.15 times 400 is 60. I'm not going to bother with that anymore. Go away. Okay. 0.4 times 400 is 160. And this will be 0.4 times negative x, or negative 0.4x. I hate x's on the right. I'm moving it over. So I've got 0.4 positive x. Now I'm moving the 60 over. Yoink, that's going to be 100. Okay. So I'm just going to divide by 0.4. And I'll divide this by 0.4, and x will give me 250. All right, let's see if we get the same thing with water. If you like to do water, no big deal, okay? So let's go ahead and look at this same stuff here. We got 400 gallons of 15% salt. We don't want that. If it's 15% salt, what's the water percent? 0.85, right? So 0.85 times 400, and we're going to now subtract or evaporate water. Well, how much percent of water is water? 100%. So you don't have to write a 1, but just you can write x. Or if you want to write W for water, write W. It doesn't matter. Okay. And again, it's the same kind of thing. We start with 400 gallons. We took away some amount. How do you write that? Well, we're going to end up with 40% salt, which means we're 60% water, and our amount will be 400 minus, we don't know the amount. Boom. Okay. So 0.85 times 400 is 340 minus x equals 0.6 times 400 is 240. 0.6 times negative x is negative 0.6x. All right. And let's move the number over here. So we'll get 240 minus 340 is negative 100. If we move the negative 0.6 over here, it turns into positive 0.6. In other words, negative 1 plus 0.6 will give us negative 0.4 times x. And if you look at this, of course, you'll divide by 0.4 and divide by 0.4. If you notice, this is almost the same thing we had over to the left, except it's all negatives. But if you do negative divided by negative, is still a positive, and there we go. So that's also going to be 250 gallons. Okay, real quickly. You've got 400 gallons to start off with, right? There, 400 gallons. 15% of that is salt. We already figured that that's going to be 60 gallons, right? So in other words, you have 60 gallons of salt. If you evaporate 250 gallons from 400, that means you have 400 minus 250, or 150 left, right? The salt goes nowhere. You still have 60 out of 150. But look at this. 60 gallons of salt out of 150 gallons of the entire solution. If you knock that down, that's 6 over 15. If you divide by 3, that's 2 over 5. 2 over 5 is what percent? 40%. That's exactly proves we're right. So there you go. Okay. All right. Hope that helps. Use that as long as you want to, the simplified version, and we'll see you next time. Thanks, guys.